has orange skin. It's actually awesome to know that we are much more similar than we think we are. Nice. So making facts that you probably don't know, part 6.
Let us see. All right. Okay. I'm setting this up live, which is weird. I'm about to go live on TikTok too. Let me put this up. Hopefully there's nothing in there. She guys not supposed to see. Let's see. Let me get my markers. I know about some new markers. All right, y'all. I'll tell you what we're gonna be talking about. Maybe make sure that this place is cool enough. Let's see. All right, I'm excited about what we're gonna talk about today. I don't have my. I'll go get it. I don't have my calculator yet. I think I'm gonna get it. And who's live? Let me hear you. So this is Jax Tutor live. So today we're gonna talk about series. Let me go live on TikTok as well. 1 second. Nope, I won't need that. You know what? I might. Let me go live on TikTok. What's going on? This is the Jax Tutor live on TikTok. If you join, say what's up. So, all right, cool. Let's see. Flip. Live on YouTube as well. So, I'll tell you what, guys, what we're going to talk about today. 1 second. Let me see if I can get this thing down for a little bit. One leg down. Probably know what's going on. Hey, what's up? Who's live? Who's that? Let me see who's live. Say what's up when you come in. While I'm fixing this whole thing, which was supposed to be done beforehand. Let's see. Let me back this up a little bit. And now we're in business. Let me see. Oh, actually, I need to flip this around. I'm tripping. All right. Okay. If you were watching this, just skip the first 2 minutes of me struggling to set this up. There you go. All right. So we are live. So today we're going to talk about a few things. Let's see. Take YouTube. All right. Today we're going to talk about a few things. Arithmetic series. Geometric series. Functions. Composite functions. And anything else that you actually want me to talk about. All right, so the first thing I wanted to talk about, let me see who's live. Hey, bro, I don't have any math problem. This school is that, yeah. Hey, what's up, Yellow? Hey, what's up, man? I know school's out, and I won't be taking a whole lot of time because I know school's out. Well, we'll just hang out for a few minutes. I plan to do this every Tuesday and get on the rhythm, and then when school comes back, we'll be taking a lot more time on it. So I wanted to talk a little bit about these. Let me see who's live on TikTok. Let's see who's live on TikTok. Last week. All right. I tutor all grades. I don't teach, actually. I don't teach in school or anything. Everyone, isn't summer? All right. So let's see. Let's talk about these. Hey, you can learn math anytime, man. So last time I remember I was at the store and I was thinking of a way to add a bunch of numbers. Um, it was I forgot what I was adding, but it was a bunch of numbers. But it turns out that those numbers follow what we call an arithmetic series. So the way it works is, so let's say you got a bunch of numbers, you want to add them. There's like, depending on how many you have, let me get my calculator 1 second. I'm trying to get my calculator. Depending on how many of those numbers that you have, there's you might not be able to add them by hand or even using a calculator. Let's say you have 50 different numbers, you wanted to add them. It might be hard for you to try to add them by hand 50 times. 50 of these numbers, that will take quite some time. Trying to see if I can put this up the right way on YouTube. So the way we do this is, let's say I have 1 plus 2 plus 3 plus 4 plus 5 plus yada 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 plus 100. So if I say, hey, let's say plus 99 plus 100, that's fine. If I say, hey, what's this total out to? So what is this total out to? So I mean, when I start counting here, I'm saying 1 plus 2 is 3, 3 plus 3 is 6. 6 plus 4 is 10. 10 plus 5 is 15. And then at some point, you're going to get tired. You know, it's 100. This could go all the way out to 1,000. This could go out to 5,000. So the way we do this, because this follows an arithmetic series, so what we do is we say, hey, let's see how we can add. Let's say we had 3 only. If we had this one, these first three only. So how would we do this? 1 plus 2 plus 3, right? That give us 6. If we had 4 only, the first 4, let's say we were adding the first 4 numbers, it would be 1 plus 2 plus 3 plus 4. That would give us 10. Okay. Let's say we were adding the first 5 numbers. And this will make sense a little bit for you. 1 plus 2 plus 3 plus 4 plus 5. That would give us 15. But like I said, you can't really continue to do this forever. So at some point, you're going to get tired and say, hey, I need a more efficient way to do this. So the formula, they come up with a formula for this, you know, after doing some calculations. People who are really smart at math, they come up with a formula for this. So they say the sum of all these numbers, let's say we call Sn, is the first term. So let's say we call this A1 plus the last term. So let me stop before I do this. So let's say we were playing around with this. So let's say we add this and this, 1 plus 3, 1 plus 3. And then let's say these are 3 terms, 1 term, 2 term, 3 terms. We'll multiply by 3. And then let's say we divide all of this by 2. Right? So what would this equal to? Let's say we divide, we divide all of this by 2. That would give us, so I take the first term and I add it to the last term. I multiply by how many terms? We had 3 of them. 1, 2, 3, and I divide by 2. That gives us what? 1 plus 3 is 4. Times 3, 12, divided by 2, that's 6. Let's see if we can do the same thing for the second one in green. So let's say I take the first term, I add it to the last term. First term is 1, plus the last term is 4. Multiply by how many terms we had? 4 terms. Divided by 2. That gives me what? 4 plus 1, 5. Times 4, 20. Divided by 2 is 10. All right, let's see if we can play around with the last one. I take the first term and I add it to the last term. 1 plus the last term, which is 5. 1 plus 5. Multiply by how many of them I have? 1, 2, 3, 4, 5. I have 5 of them. And I divide by 2, right? So what does that give me? 1 plus 5, 6 times 5, 30 divided by 2 is 15, which is the same 15 that we had here. So as you could probably tell, is for those 100 terms. So for all of those terms, so what I can do is take the first term, 1, plus the last term, if I wanted to add those, 100, multiply by how many terms I have. 100 times 1 is, 1, 2, 3, 4, 5, 100 terms total, divided by 2. Does that give me what I'm looking for? So, does that give me what I'm looking for? 100 plus 1, or 101. Multiply by 100, you add two zeros, divide by 2. Is that 50 something? Let's see. Where's my calculator? You guys can give me what this would go to. About 50. What's that? Oh, 1 second. This is 10. 100 divided by 2. Divided by 2, not 5. I give you 50, 50. 5,000. Not 50. 5,000. 50. All right. So what this telling us is if I put all of these in the calculator, I add them up all the way down to 100, I add 1 plus 2 plus 3, whatever I was doing here. If I continue to the 100, that would give me, that's going to give me 50, 50. So the formula that we need to come up with for that is not come up with. The formula that we need to write for this is, so what is this? What does that say? It's the first term plus the last term multiplied by how many terms we have divided by 2. Let me see if you guys have any questions. Questions? Let's see. YouTube, any questions? Nope. All right, let's see. Any questions? TikTok. Let me see if you guys have any questions. Thank you, Nat Lyrsay. Appreciate you. Quadratic. Do you mean quadratic equation? Let's see. Thank you. I appreciate you. Whoa, the calm down. I think I whoa, the calm down. I appreciate you the comment. All right. So the person who asked about quadratic, you mean quadratic equation? Yes, quadratic equation. All right. Now, I'll put that on the board. So are you trying to find a way to solve for them? Graph them? Quadratic equation. Quadratic equation. So specifically, what do you want to know about them? Are you trying to graph them? Are you trying to solve for them? Are you trying to use the quadratic formula? What is it that you want to do with the quadratic equation? All right, so from this, we can go to geometry series. Let's say we have a bunch of numbers, and I'll make it simple. So the first one that we saw was if I'm adding a sum of a bunch of numbers, all I have to do is add the first one, a1, plus the last one, an, multiply by how many of those numbers I'm adding, divided by 2. So that's the first one that we're looking for. But like, what if this is for arithmetic? And what if it's the geometry? geometric series. So let's say I have a number. So like when you have a geometric sequence, so when you have a term, to find the next term, you multiply it by a constant ratio. So it could be you multiply by 3, multiply by a constant number. So it could be multiplied by 3, multiplied by 5, multiplied by 1/2, multiplied by -15. So let's say I have this 1 plus 1/2 plus 1/4 plus 1/8 plus let's say I have 1 over I don't know, plus a bunch of other numbers. So let's say I have this series right here. So I wanted to add them. I wanted to add the first 50 terms of these series. So the way I would do that is actually using a simple formula. So the formula to find those, the sum of these so the first thing you need to know is what is it that I'm multiplying by to get the next term. So I start with 1. What do I multiply 1 by to get the next term? Of course, I multiply it by 1/2. And then 1/2, I multiply 1/2 by 1/2 again to find the other term. I multiply 1/2 by 1/2 by 1/2 again to find the next term, which is 1/8. So the constant ratio here that I'm multiplying by, call it R, it's 1/2. And then the first term is 1. The first term that I have here is 1. So let's say I wanted to add all of these terms. So let me see if you guys are with me. YouTube. Say I wanted to add all of these terms. Can you guys give me a hint on how we would add all of these? I say geometric series here. So how would you add all these terms? Okay, let's see. So let's say we call this first term here. We'll call the first term here A. A is 1. And then we call R by the ratio that we're constantly multiplying by. And I wanted to add the first 50 terms. So 50 terms. So that means N is equal to 50. So the formula that I want to use is the first term multiplied by R to the N minus 1 divided by R to the N minus 1 divided by R minus 1. So what does that mean? What it mean is, so what I want to do here is, if I want to find the 50th the sum of the first 50 terms of this series. So if I want to find the sum of the first 50 terms, so S50 is equal to the first term, which is 1, multiplied by R to the N. N is 50. R is how many? What's the constant ratio that I'm multiplying by? Ratio R. So the constant number that I'm multiplying by, let's call it R. So R in this case is 1/2. If I'm summing the first 50 terms to the 50th minus 1 divided by 1/2 divided by R minus 1. So how do we find this? So this denominator 1/2 minus 1 is -1/2. When you flip that, you multiply by 2. That 1 is going to go away. So that would be 1/2 to the 50 minus 1. And this 1/2 means that if you divide by 1/2, it's the same thing as multiplying by 2. So you would get -2 times -1/2 to the 50 minus 1. So let me not go so far. So let's say we wanted to add the first 3 terms, which is these 3. Let's say if we can find if what we're doing is good, is actually good. So let's say we wanted to add the first 3 terms. So let's say we were adding 1 plus 1/2 plus 1/4. So if I go in the calculator, I type 1 plus 1/2 plus 1/4, that would give me what? 1 plus 1 over 2 plus 1 over 4. That gives me 7 over 4. So let's say if I using the formula that they came up with for this is the sum of all the terms of how many terms you have is the first term a 1 minus r to the n minus 1 divided by r minus 1. So the first term is a, which is 1 in this case, the sum of the first three terms. So when I go in the calculator, I find the sum of the first three terms is 7 over 4. So the first term is a, which is 1, r to the n minus r to the n, so r to the 1, 2, 3. So I'm adding 3 terms. So r is 1/2 to the third power minus 1, and then 1/2 minus 1. Is that equal to 7 over 4? Let's see. All right, so that one, you don't have to worry about it. The 1/2 minus 1 in the denominator, 1/2 minus 1 is minus 1/2. So 1/2 to the third is 1/2 times 1/2 times 1/2, which is 1 over 8 minus 1. So this is what I'm solving for. 1 over 8 minus 1 divided by negative 1/2. So 1 over 8 minus 1 is what? So if I have 1 over 8 minus 1, you can use this trick always. 1 minus 1. 1 times 1 is 1 minus 8 times 1 is 8 divided by 8 times 1 is 8. So that gives me what? Negative 7 over 8. You have that divided by, we have this whole thing, so that means I have negative 7 over 8 divided by negative 1/2. That negative cancels, so I have 7 over 8 divided by 1/2, which is 7 over 8 multiplied by 2, which is, simplifying by 2, 7 over 4, which is the same thing that we had here, 7 over 4. So if I have a series of, a geometric series, the way I add them, take the first term, and then I take the common ratio, r to the n power, minus 1 divided by r minus 1. So that's how you would do it. If you wanted to try adding those first 4 numbers, you would get the same. You can add them yourself, and you get the same thing. So this is how we prove that for the first 3 terms. This is true. Of course, it's true because you can look up the formula and find that people have been using this formula for a long time. The only thing is when you're using these, remember when I'm adding n term. Remember what n term means. So that means when you start counting, you're counting this as the first term, this as the second term, this as the third term. So, so just remember the way you try to count those. So, let's see. Yeah, that's it. I think this should do it for this one. 7 divided by 4. All right. So let's see if you have any questions. Let's see. Quadratic formula. I'm here. Even though school's over. Thank you. Thank you. I appreciate you being here. Even though school's over. I'm sure you learn. I hope you learned something here that you can use next year. Let's see. Any other questions? Nope. There's no more questions. All right, cool. Let's see if we can do functions, specifically composite functions. The person who asked about quadratic formula, do you want to know how to use quadratic equation? You want to know how to solve them, how to graph them? Yes, I can do AP Calc. Shaquille Oatmeal 595. Yes, I can. Yes, I can do AP Calc. Yes, quadratic equation. Not liars say. You want to know how to graph them or just what you want to know about them? Because that would be helpful information for us. All right, so let me go on to something else. All right, so functions. So there are many kinds of functions. There's what we call linear functions. So let's say, things that look like a line. There's also quadratic function, which probably going to talk about a little bit. There's also exponential functions, powers, and there's also log function. There's also, trig functions. So what I specifically wanted to talk about here that people sometimes have problems with is is composite functions. So composite functions is when you take a function and you put another function inside of it. So that's kind of like a loose way to define it. But let's say I have a function here, f of x, and that's 2x plus 3. And let's say I have a function g of x that is, let's say, negative x plus 1. So let's say if I wanted to do the composite f of g of x. So if I wanted to find that composite function, how do I do that? So what I would say here, I'm going to go inside of the f function. Every time I see f, I'm going to replace it by g of x. So the way you could write this is f of g of x. So the only difference between this here and this is inside of the function, instead of x that was here, I have this whole thing called g of x. So I'm going to go inside of this function. Every time I see x, I'm going to replace it by g of x. So every time I see x, I'm going to replace it by g of x. Let me know if that makes sense for you guys. And I can explain this using a different approach to explain this. So let me know if that makes sense for you. So f of g of x, I'm going to go inside of the f function, f of x function. Every time I see x, I'm going to replace this by g of x, because that was the difference between this and this. So this is f of x. This is f of g of x. F of g of x. Every time I see every time I see x inside of this function, I'm going to replace it by g of x, which is this whole thing. Let me know if that makes sense. Hold on. If I confuse you, does that make sense? I appreciate you. No problem. Irrelevant titanium. Is that what it says here? No. Not titanium. No. Yeah, no problem. All right. Does that make sense to you guys? Yeah. Okay, good. All right. So let's proceed. So I'm going to go inside of this function. F of x was f of x. F of g of x now is going to be what? F of g of x is 2. Remember, let me leave this space empty because I'm not going to put x in it. I'm going to put something else in here plus the 3. So I basically write the f of x function. So what I'm going to do here, inside of here, I'm going to replace that by what? G of x minus x plus 1. It's not magic. So the 2, that f of x was 2x plus 3. 2 times the input plus 3. So inside of the x function now it's a different input. It's not x, it's the whole g of x. So I have 2 times the input, which is g of x, plus 3. So this is what we're gonna evaluate now. 2 times the input, g of x plus 3. So it's 2 times, I put the 2 in red. That don't matter. 2 times negative x plus 1 plus the 3. Okay, so what's 2 times negative x, negative 2x? 2 times 1 plus 2 plus the 3. Don't forget that 3 because that's part of the function too. And that's what people normally confuse. They forget that 3 outside or whatever number was not part of this x. So negative 2x, 2 plus 3 is 5. Yeah, did we do that right? Negative 2x, 2 plus 3 is 5. And then if you want to do g of f of x, is the same approach. it won't necessarily go to this. It's the same approach though. You go inside of the G function, you put f of x. Let me know if that makes sense, and we're gonna move to quadratic equation. Does that make sense for you guys? Let's see. Thank you so much. No problem. No problem. All right. Okay, let's see. Quadratic equations. All right, so not liars say, I hope you're still here since you asked the question. So I'm not sure exactly what you necessarily wanted to know about it. So let's say we have an equation of f of x is equal to ax squared plus bx plus c. Now, this is what we call a quadratic equation. So the highest power of this equation is 2. So that's the power, that's the highest power. Then you have an x, and then you have a constant that doesn't have x in it. This equation, there's multiple things that you can use this equation to describe free fall. You can also graph this equation. So usually it will look something like, something like this, something like that. It depends on all of those coefficients, of course. So, but let's talk about solving this. So let's say we had this equation here. We wanted to know how to solve for it. So if you're solving for this, that's what we call the quadratic formula. But also, sometimes you're able to factor this. And if it cannot be factored, or sometimes it cannot be solved in real numbers as well. But sometimes by looking at this, you're able to factor it. So let's say I had x squared minus 6x plus 9. You can factor this, This is, let's say I had, so yeah, you can factor this easily. So that would be the same thing as x minus 3 squared. Of course, you could have something that factors into x minus 1 times x minus 5. You could have an equation like that, or x plus 5. That could be in a quadratic equation. But sometimes you're not able to see the fact what does that factors into. So you use what you call a quadratic formula. So in order to solve for x, it would be x is equal to minus b plus or minus the square root of b squared minus 4ac divided by 2a. So what are these numbers? Those a's, b, and c are the same thing that are here. So the b here is the same b here. You just take the negative of it. That's the b also. The a here is the leading coefficient for the x squared. And then that's what's here, and the c is here. So let me give you an example. So let's say we had x squared minus 5x plus 6, right? I say plus 5x plus 6. Okay, so let's say we wanted minus 6. Let's say we wanted to factor this. So how do we factor this? The first thing, we can try to factor it. We can try to factor it using, okay, can we factor this? Can we factor this just by looking at it? So what are two numbers? The way you factor those, what are two numbers? When I add them together, I get negative 5. I get 5. And when I multiply them, I get negative 6. So let's think of those two numbers. So the way I like to do this sometimes, first of all, I don't think of the sign, and then I figure out what sign I need to put in. So I think of what are two numbers, when I add them together, I got 5, and when I multiply them, I get 6. So two numbers, when I add them together, I get 5, and I multiply them, I get 6. So I go straight into the multiplications because it's going to be a lot less cases. What are two numbers when I multiply them? I get 6. I can multiply 1 times 6, or 6 times 1, 2 times 3, or 3 times 2. It's the same thing. And there's no other cases, you know. So, so 2 numbers are multiplied to get 6. And when I mean numbers is, you know, integers and, you know, things that are not fractions and stuff like that. So when I multiply these 2 numbers, I get 6. 1 times 6 is 6. 2 times 3 is 6. But when I add them, I also get 5. So this is where I go into the signs. Sometimes if I add them, when I add these 2, I get 7. But if one of them was positive, one negative, I can get plus or minus 5, right? Okay. But in this case, when I add them, so 2 and 3, when I add 2 and 3, what do I get? I get I get 5. 2 plus 3 is 5. But when I multiply 2 and 3, I get 6, right? So let's go look at those 2 cases. So which one of these is it? So if I take 2 and 3, 2, if both of them are positive, 2 multiplied by 3 is 6. Here I have a negative 6. That means one of them is positive, one of them is negative. So that means either the 2 is negative or the 3 is negative. Because when I multiply them, I get a number that's negative 6 out here. So either I have negative 2 times 3, or I have negative 3 times 2. Which one of these is it? Negative 2 times 3 is indeed negative 6. This also is negative 6. But when I add those 2 numbers, negative 2 plus 3 is 1. Negative 3 plus 2 is negative 1. So these are not, when I add them, I don't get 5. In this case, 1 in negative 6. We know because the sign in front of the 6 is negative, that means one of them is positive, one of them is negative. 1 times 6, 1 times, so either I have a 1 times a negative 6, or I have a negative 1 times a 6. 1 times negative 6 is negative 6. Negative 1 times 6 is negative 6. So that gives me that. That's checked. So let's go into the 5. 1 minus 6 is negative 5. That's not what I have here. I have positive 5. 6 minus 1 is 5. So 5. So these 2 numbers that I was looking for are negative 1 and 6. Okay. So now what does that factors into? So that would be x plus 1 times x minus 6. Okay, so if I have x plus 1 times x minus 6, does that give me this? So x squared minus 6x minus x, so it's the other way around, x minus 1, x plus 6. So these are the 2 numbers that when I add them, so the factor that I'm looking for is x minus 1, x plus 6. So if I multiply these 2 factors together, x times x squared minus x plus 6x minus 6, which is give me x plus 5x minus 6. So that's the first way to solve for this. Let's say if I didn't know what this would be equal to. Let's say if I didn't know, if I'm like, okay, I don't know how to factor these, how do I solve for it, for x? So what do I have? X squared minus 6x plus 5x minus 6. All right, so let's say if I have this here, no problem, Leanne Garnett on YouTube, Leanna Garnett on YouTube. Okay, so let's say I had these right here, and I said, hey, how do I factor these? So if I didn't know, if let's say I wanted to solve for this equal to 0, let's say I wanted to solve for f of x is equal to 0, how do I solve for that? So the first thing you do is Using, if you want to use the quadratic formula, you say, hey, x is equal to minus b plus or minus the square root of b squared minus 4ac divided by 2a. So what's b? So what's b? b is 5 minus 5 plus the square root of 5 squared. Let me separate these two so you know where I'm at. So the square root of 5 squared minus 4 times a, which is 1, times c, which is negative 6, divided by 2a, 2 times 1. Okay, so that looks kind of messy. So what do we get from here? So minus 5 plus, let's do the plus 1 first. 5 squared, what? That's a plus minus. We can do this. 5 squared is 25. Square root of 25. 4 times negative 4 times negative 6 is 24. Minus 24. Divided by 2 times 1 is 2. Minus 5 plus or minus 24. 25 minus 24 is 1. Square root of 1 is 1. Plus or minus 1 divided by 2. So it's minus 5 plus 1 over 2, which gives you a number. And minus 5 minus 1 over 2, which gives you another number. So what does that lead to? One of these is minus b squared minus 4ac, 25 minus 24 divided by 2 is what? So 5 plus 1, negative 4, divided by 2, negative 2, and then I'm getting 3. Huh, interesting. Did I factor this correctly? Negative 2 and negative 3. Oh, Lord. That shouldn't be the case. Let me see. Hold up. Let me see. What you got? Let's see. Hold up. Thanks for doing this. So nice of you. Appreciate you, Daphne. Great, Terrell. All right. Any other questions? No problem. Mania next door. I don't know. Colleen Beeson? I don't know. My teacher just something like a next, and I don't get it. I'm not sure what you're referring to. I didn't hear that. The person who asked about California getting rid of the SAT by 2024, I didn't hear that. I've heard some people say it might be taken online. I didn't hear much of that. That's interesting, though. Yeah, this is quadratic we're doing. Enough is enough. This is quadratic we're doing. So I'm not sure what do you want to do in the quadratics? Is like, do you want to know how to solve for them, factor them? No problem. The person who has a test tomorrow. you would have to show me the sequence. We're just talking about sequence and series. You'd have to show me the sequence so I can find the first 5 terms. So depending how they define it, you can find the terms easily. You'd have to show me the actual sequence. Yeah, so all right, let me try to put these in the calculator. Let's see. So if I plug this in the calculator, what did I get? -2 and -3. Negative b plus or minus b squared minus 4ac divided by 2a. So that would be -5. 25 minus 24 plus 1 divided by 2 minus 1 divided by 2. -2, -3. -2 squared is 4. So if I plug in -2 here, -2 squared is 4. 5 times -2 minus 6. So -2 squared is 4. 5 times -2 plus 5 times -2. -2 squared is 4. 5 times -2 is what? My eyes are running. -2 squared is 4. 5 times -2 is -10 minus 6. We made a mistake somewhere. All right. Let's see. Hold up. It should be 1 and 6. I don't know why I'm getting this. All right. Let's start this all over again. Okay. All right. So x is equal to minus b plus or minus square root of b squared minus 4ac divided by 2a. So negative b minus b, which is 5, plus, let's do the plus first, square root of 5 squared is 25, minus 4 times a is 1 times c is -6, divided by 2 times a, which is 2 times 1, which is 2. Yes, I know I was making a mistake. All right, so it's -5 plus square root of 25 plus 24. I had 1 earlier when I did it, divided by 2. I was wondering why I was getting -2 and -3. So, -5, square root of 25 plus 24, that's square root of 49, plus or minus square root of 49 divided by 2. -5 plus or minus, what's the square root of 49 is 7, plus or minus 7 divided by 2. So what does that give us? 5 plus 7 over 2, which is 12 over 2, which is 6. 5 minus 7 over 2, which is -2 over 2, which is -1. So answers that we got before, -1 and -6. Now notice that the zeros are -1 and -6. The factors are x plus 1 times x minus 6. Is that what we're saying? V1 factors is x plus, what am I saying? X minus 1, x plus 6. Is that it? 6 times 1 -6 minus 5. So the factors are x minus 1, x plus 6. And yeah, that's how you do this. So this factors into x minus 1 times x plus 6. If I follow x minus 1 and x plus 6, What do I get? X minus 1 times x plus 6. What do I get? X squared plus 6x minus x minus 6. X squared plus 5x minus 6. Right? Yeah. And this is what I made a mistake. So minus 5 plus or minus 2 over plus or minus 7 over 2. So that gives me 1 and negative 6. So the zeros are 1 and negative 6. I don't know why that's taking me so much time. The zeros are 1, negative 6. The zeros are 1 and negative 6. And then the factors are x minus 1, x plus 6. So if you want to go from the zeros to the factors, x minus this 0, x minus that 0, x minus 1, x plus 6. Quadratic. All right, so this was supposed to be easier. I don't know why it takes me like 10 to 15 minutes to do this. Maybe trying to explain it and do it at the same time. And then putting everything in one spot, that'll help. All right, let's see. What else we can say about quadratics? So sometimes if you have a few points you can draw. You can really graph the equation. So the key points that are going to be important for us is, let's say we have something that looks like this. Sometimes you get lucky, you get that. So some of the key points that are going to be important for us is the intercepts, and then also the vertex. So to find the intercept, the x-intercept and the y-intercept, so what you do is, so let's say you have f of x is equal to ax plus by, x squared plus bx plus c. The x-intercept is, so where is the function, this is the f of x function, intercept the x-axis. So the x-axis is intercepted right here and right here. So when the function intercepts the x-axis, the value of y is equal to 0. As you can see here, if you were marking this point, this could be the point 1, 0. This could be the point 3, 0. So the value of y in both cases are 0. So that means if y is equal to 0, y is the same as saying f of x. So that means the function is equal to 0. You set that equal to 0. Now, as for x-intercept, you set the y is equal to 0. It's like vice versa. So y-intercept, you're going to set that x is equal to 0. So at y here, let's say this was the point, 0, 5, you can see the x value is equal to 0. So what you can do is you go inside the function. Every time you see x, you replace it by 0. So you would be, so let's say if I had a function f of x is equal to the same one we had, x squared plus 5x minus 6, the y-intercept would be 0, negative 6. So that would be somewhere right here. So, and the x-intercept is that way too. I had a question, quadratic unit a while ago. It was hard. When you explain it, it makes sense now. Oh, thank you, Michaela Crenshaw. Thank you. I appreciate. I wish I was good at math too. I appreciate you. Your comment. Thank you. Yeah, I'm glad that it makes sense right now. Okay, cool. So, let me see if the person who asked questions about quadratic has another question. Do you have any other questions? Let's see. Any other questions? What's 4 plus 1? That's a hard question. Anybody knows? Yeah. 2 plus 2. That's another tough question. Quadratic formula. Yeah, that's what we just went over. No, that's not chemistry. All right, cool. So I think this is probably gonna be it. Let's see. Nope. Let me flip the camera. All right, guys. Hey, yeah, this is it. I know you guys are not in school. Most of you guys are not in school right now, and I just wanted to stop by and also continue to do this, so that way when the school start again, you'll be able to have something to refer back to, and we're always trying to do this every Tuesday and make sure that you guys can call in and enjoy. So I appreciate you guys showing up for this, and I hope y'all have a good night. If you have any question now, if you have a question that you want me to help with, please send it to 904-299-8417, and that's the best way to, because a lot of times you guys are asking questions. The subject that you want the questions answered to is so broad, just like the question about quadratic. I've done all this. This may not be what the person wanted to hear. So when I see your question specifically, I can I have more directions, and I'll be able to help that way. And it's free. Just text the number is 904-299-8417. That's where you can text your questions. I'm gonna text it right here, and it's on all. If you go into any of my 904-299-8417. 8417. So if you go to any of my my channels, you're probably gonna see the number. So all you have to do is take a picture of whatever you're working on, send it to me, and then when I come live here, it'll be one of the first things I answer, and I'll be able to to look at it and see exactly what you need help with, instead of coming here and give you broad example. Does that make sense? I have some stuff that I normally prepare to work on, but in addition to that, what I prioritize is your questions. So whenever you send it to me, I'll look at it and then explain it to you guys. So I just text the number on text all questions to I just text the number on TikTok. I'll put it on YouTube, 904-299-8417. So when you text that to me, it comes to my phone, and I'll look at it and I see it. And then I'll reply to you. Don't just say I need help. I actually take a picture of what you need help on, and then I'll see it. All right. If you don't any questions, guys, do you understand what I was working on? Person man 10101. I just text the number. So let's see. All right. I don't see anything else. All right, guys. It was nice hanging out with y'all. And everyone on YouTube too, thank you for showing up. I know this is probably showing up weird for y'all on YouTube. Thank you for showing up to this live session. And I'll see you guys on Tuesday. We've been live for almost about an hour, probably a little bit longer on YouTube, because I started that before it. I hope y'all have a good night, and talk to y'all later. Thank you. Bye.